Hey guys, welcome back to the next video. In this video, we are going to understand what is namespace, and then we're going to see one example. And then on the next video, we are going to be working on a real-time example. What this particular presentation is talking about. That's what we are going to execute on the next video. Now, do remember that the next video would be on Udemy. So that's pretty much where you want to check it out on the next video in terms of hands-on towards it. But then this video is talking about the three different namespaces and how, within one, your cluster of your Kubernetes cluster, how these three different namespaces are going to be unique to each other. And we are also going to talk about some kind of hands-on this video as well, just to understand some beginning details about the namespace. Now, to start with, the namespace is a logical organization of your application deployments, which is to be managed by your Kubernetes. Now, as you can see in this architecture, we have organized our deployments in three different environments. So you have environment of development, testing, and production, and this will logically create a boundary between these applications. So in which that you can segregate the application level of security, which does not affect one level of security does not affect the others, and you're going to have individual services as well as part of this. So a lot of things we're going to do on the hands-on session. So let me explain you one by one. So by default, your Kubernetes itself is providing a lot of namespaces, which is by default configured. So if you do a kube control get namespace, right, so you can see that there are so many namespaces which is available over here. So which means that under each namespace, you will have its own related pods. Now, we have already seen some namespaces here. You can use -n to specify a namespace. So kube system is a very much a familiar one, which we have seen. So now, apart from this, the one more namespace which we have installed is the final namespace. So this is a separate entity we have downloaded and installed it after installing Kubernetes. So this itself forms a namespace, and that comes under kube, which means that it is kube internal one. So this funnel is a networking agent which is going to sit across all your worker nodes and your manager node, and it's going to facilitate a network for connecting all these nodes together. So that itself is another internal namespace. Likewise, you have public, node release, and likewise two other namespaces available. You know the default namespace. This is where all your, if you're not specifying any kind of a namespace to any of your deployments or pods or anything like that, it's going to end up in this default namespace. So whatever you don't mention, it's going to end up over here in one namespace over here. So this is pretty much what I wanted to show you as a hands-on. So likewise, you can create namespaces based on monitoring database. Likewise, you can create namespaces. You can also create namespaces by segregating your environments like dev, prod, testing, likewise also. Or you can put it like web namespace, app namespace, database namespace. Likewise, you can separate it as well. Now, this gives you a control over a specific namespace. So I found this development, production, and testing is more commonly used on any such environments which we use as a different namespace. So I found it logical to use it in this way. And when we talk about the API services, which is going to be used part of the namespace, some API services has compatibility with namespace, some doesn't have. So what I'm trying to tell you is that when you use this command, let me just bring this up a little bit. Kube control. When you type kube control API resources over here, it's going to give you the amount of API resources which you have over here. Now, this is something which we have seen on the previous video as well. Now, what you have to look for or look out for is the namespace over here. So, according to this kind, it tells you whether it supports a separate namespace or not. Some doesn't, some does. So, you can see that binding does support. Likewise, you can see persistent volume doesn't support a namespace. So, but persistent volume claim supports a namespace. So, which means that you can define a persistent volume, which is common for all the namespaces, but then what you're going to claim from that persistent volume can be individual to each namespace one. So this is very good example right now what you're looking at. So when you're using persistent volume, you'll be utilizing commonly, but then when you do this persistent volume claim where you're actually implementing the persistent volume, that time you can actually do it for individual namespaces. So that's something which you should remember. So if you want to know whether certain things like deployments, replica set, stateful set, daemon set, so all these supports namespace, as you can see over here. So namespace is used more or less on your cron jobs, on your jobs and everything else, and even Pod Autoscaler also does namespace support. So which means that most of the items over here can support namespace, which means that it gives you opportunity to segregate or to logically organize your application or divide your application logically and then organize them in a different way. So that is quite possible. So if you want to know that, this is the best option for you to understand about the API server or what it supports as a namespace or not. That is something I want to do that. I do want to add it over here. Namespace will have different teams to manage your authentication by on a cluster by adding necessary security with the role-based authentication. So that is also possible with namespace, and you can also put in firewall between your application pods based on the namespace as well. There are a lot of use cases for namespaces. Okay, so this is pretty much I want to cover on this video. And what we are going to do on the next video towards hands-on is that we're going to create these three environments over here. So we are going to firstly create three namespaces. I want to use the optimized method. So I'm going to have one namespace.yaml file which creates three namespaces. So one for environment development, which I'm going to use dev as a namespace name, and here it's prod and then test. So in one file, I'm going to comprise of all these three namespaces, then execute the file and have these three namespaces created. And I'm going to do a deployment in one file again. So all three, namespace deployment would be coming under one single file only, so that I can show you that option as well. And it's very simple, just create it separately and then put them all together. So I'm going to use two items for these stuff. One is basically the worker data over here. Worker 1 will be aligned to the development, and worker 2 is aligned to my test environment, and it's going to use versioning of Nginx 1.16 on across all three namespaces. But then the directory or the host path which is going to mount on these namespaces will use the individual files, and you can actually use the load balancer node port number of 30,001, 2, and 3 to browse your application. And when you browse the application with the different port numbers, you're going to find different content. So we need to align this content accordingly so that the development website will have welcome to dev.com, and test will be welcome to test.com, and the prod will be welcome to prod.com. So that's going to individually, because you're going to have three different mount points mounting to your Nginx directory. So there you're going to get three different websites also as part of this particular example or hands-on video. So these are the things which we're going to do on the next video. I'll see you on the next video towards a hands-on and getting this successfully deployed using these three different namespace. Thank you again for watching this video. I'll see you on the next one.